Well, hey there, kiddos. Today we're going to finish up your pink and white book so that we are finished with our introduction to quadratics. I will try to keep this shorter than the one that you had to watch over the weekend, but I can't make any promises because there is a lot of information here. You need your pink and white book and calculator if you have it with you. So the first thing we're going to do is we're going to talk about what we did. You worked on some of this today. You were given a function and you were asked to find the vertex, line of symmetry, and all of that just from the picture. Now we're going to do it from a function, and we're going to use our calculator to do it, which is going to come in handy, especially when you have some of those problems like you had today where the vertex has decimals and so things are all weird. So we're going to show you how to use your calculator. So this first function that we have is this y equals x squared minus 6x plus 11. And so the first thing we're going to do is we're going to put that in our calculator. So we're going to go over here to y equals, and we're going to type in x squared minus 6x plus 11. And Miss G is going to go back and double check that that is really the function we're looking at. And then we're going to graph it because we want to see what it looks like. And so I'm going to hit graph so that it draws the picture of the parabola. And so there is that parabola, and I can see that the vertex is somewhere around 3, 2, but without all the little grid lines it's kind of hard. I'd just be guessing. So we're going to have it find it for us. But first, what I want you to notice is this parabola is concave up because it opens upwards, and so that makes my vertex a minimum. So I can go over here and answer 2 questions right off the bat. This has a minimum because my vertex is the lowest part of the graph, and it is concave up because it is opening upwards. So I'm going to go back here and we're going to actually find where the vertex is. We're going to have that calculator calculate it for us. We know it's a minimum because we just talked about the fact it's the lowest point of the graph. So we're going to go to second and trace. That's our calculate menu. And there on the calculate menu you see option number 3 right here is it says minimum. By the way, the steps would be exactly the same if you wanted to find a maximum instead, but we want the minimum because it's the bottom. And so now we can't just go enter, enter, enter like we have done in the past. Now it's going to ask you some questions, and the first question it's going to ask you is for the left bound. What that means is, where is the left side of the vertex? That's what it's basically saying, okay? So you're going to have to tell it where the left side of the vertex is by putting your cursor over here to the left of the vertex. I can't see my cursor right now, so I'm going to just start hitting my arrow. There it is. So I'm going to hit my arrow button, left and right arrows, until I get my cursor somewhere to the left of my vertex. That looks like it's to the left of my vertex, and then I'm going to hit enter, and what that's going to do is it's going to mark it. Now your calculators won't draw the line here, but it will put this little arrow up here. And this little arrow is saying, okay, left side of the vertex is over here. Now it says right bound, which means where's the right side of the vertex? So we're going to do the same thing. We're going to move our cursor over until we are on the right-hand side of the vertex. And so that's to the right of the vertex, and we're going to hit enter again, and again it's going to mark it. So it's going to put this little arrow up here. So it's saying here's the left side, here's the right side. Now it's asking for a guess. And we do really want to make a guess because we kind of want to tell our calculator where to look. And so my vertex is about right there, and I'm going to hit enter, and it's going to give me some weird numbers. The first value is x equals 2.999999, and then it rounds off 87. When you come up with a number like that, your calculator doesn't have enough memory to calculate it exactly because it's hanging off out there in the middle of no man's land. That's telling you that you really need to round. It's going to be 3. So we're going to call this 3, 2. Now if it says something like 2.5, you're going to leave it alone. But that 2 and then the 99999 business tells me that I'm going to call that a 3, 2. So there's my vertex. My line of symmetry, if you remember, is just the x value of the vertex. So it's going to be at x equals 3. And my domain, well, it's a parabola. I didn't see anything that said there were endpoints, so my domain is going to be all real numbers. My range, because this is concave up, is going to, and it has a minimum, is going to start at the y value of my vertex, so it's going to start at 2 and go to infinity because it's opening up. You can also just say y is greater than or equal to 2 because it starts at 2 and goes up. So I'm going to have you pause, and I want you to try that whole process again. Plug the next thing into your calculator, decide if it's a minimum or a maximum, go find it, and then answer the questions and come back and check your answer. So I plugged everything into my calculator, and I graphed this, and I see that it is a parabola that is concave up because it opens upwards, so it has a vertex that is a minimum. It's the lowest point, and that minimum is at -3, -5. Now, when I plugged mine in and I did it on my calculator, my x value came out to -3.0000000, which tells me round off to -3. It's the same thing as the 9999 stuff. The 000 means the same thing. Anything else in the middle, you probably don't want to round. That tells me my line of symmetry is at x equals -3 because it's just the x value of my vertex, and then my domain is all real numbers, and my range is all of the values -5 and greater because it starts at -5 and goes up. So that's how you use your calculator to do that. If you need to practice it again, by all means, pick a different equation from somewhere else in your notes. Go practice that again using the steps we did for the first one. So let's turn the page. Down here on page 5, now we're going to talk about multiple representations, which you have seen before. We've dealt with these before with linear functions. Now we're going to do it with a quadratic function. And so multiple representations, the first one is always the equation or the function, and then give you the equation here. It's y equals 2x squared minus 8x minus 3. I take that back. That says y minus 2x squared equals 8x minus 3. Well, the first thing that needs to happen is I'm going to put this in standard form. So I'm going to get that y by itself by adding 2x squared to both sides. So my equation in standard form is y equals 2x squared minus 8x, plus 8x, because that's a positive, minus 3. And so I'm going to use my calculator to get the numbers for this graph and do what I need to do. And I need it in standard form in order to do that. So one of the representations is definitely going to be the equation in standard form. Then I could also have a table, which, by the way, our calculator will give to us. That's why it's such a nifty little piece of equipment. I now know the equation in standard form, so I'm going to go back to my calculator. I'm going to go to y equals, clear out that equation, I'm going to enter in the new one. So I have 2x squared plus 8x minus 3. And instead of looking at the graph this time, I'm just going to go look at the table. So I'm going to go second graph so I can look at the table of values. And the table I have on my paper starts at -4. So I'm going to arrow up here so I can see it at -4. And I see that at -4 it's at -3. And at -3 we're at -9. At -2 I see that at -2 we're at -11. At -1 we're at -9, and then at 0 we're at -3. So we're back at -9 and back at -3. So you can see there's some repetition here, and it should happen because we're dealing with a parabola. We have a quadratic. So there's the table. The mapping is just like we did when we had linear functions, but it's been a while, so we're going to remind ourselves. When I do a mapping, I have my two ovals. Hopefully you draw better ovals than I do. This one's x's, this one's y's. And I list my values in order from least to greatest. So my x's are already done. -4 to 0. But my y values need to also be in least to greatest order, and I don't write repeaters. And so the smallest one was -11. And then I had two -9s, but I'm only going to write it once. And then I also had two -3s, which I'm also only going to write once. And so now I'm going to just draw my mapping. What goes with what? Well, the -4 goes with this -3. The -3 goes with -9. -2 with -11. -1 goes with -9. And 0 goes with -3. And so that's what my mapping would look like. It just says map this number to that number, just like a little guide. Now the graph is real easy because I have points, and I'm just going to plot these points onto my graph and then make the parabola. And so I'm going to start with -4, 1, 2, 3, 4, -3. And then I have -3, I probably should go down further. -9. And then I have -2, -11. And then I have -1, -9. And then I have 0, -3. And so there's are my points. I'm going to connect them with a smooth curve. That's my parabola. It's concave up. My vertex is a minimum. And so now let's talk about the domain and the range. Well, arrows on the ends, all real numbers for the domain. The range, because this is concave up, is going to start down here at -11, because that's that y value right there. and go to positive infinity, or it is all numbers greater than or equal to positive or to negative 11. So it starts at negative 11 and just goes up from there. So that's how we do multiple representations. Just several ways to see the same thing. So now let's talk about the difference between linear functions and quadratic functions. A linear function, you remember, the parent function was always y equals x. And if I had something that was linear, that meant that I always had a constant rate of change. So that constant rate of change we called the slope, but it was always the same. No matter where I was on the graph, no matter where I was in the table, the rate of change was identical. And so it was easy to tell if something was linear. When something is quadratic, the parent function is y equals x squared. And so they don't have a constant rate of change on first look. We usually have to take a second glance, and I'll show you what I mean. So let's just check this. Number one, we're going to see if it has a constant rate of change. All of my x values here increase by 1. So I'm not really concerned about what's happening here. But my y values, on the other hand, that's what I want to look at. So from 10 to 7, that is a decrease of 3. From 7 to 4 is still a decrease of 3. That's a decrease of 3, a decrease of 3, and this is still a decrease of 3. And so you see that I have a constant rate of change, minus 3, minus 3, minus 3. That makes this a linear function because it has a constant rate of change. The slope of that function is negative 3. And so my rise over my run would be negative 3 over 1. I could graph it, find the x and y intercepts, do all of that. But that's how I tell if it's linear. Is the rate of change the same the first time? When it's quadratic, here's the way I remember this. Quadratic functions always have an x squared in them. And so if I want to know if something is quadratic, then the second differences have to be the same. And here's what I mean by that. If you look at this table, again, all of my x values increase by 1, so I'm not going to worry about those. What I'm going to look at is the y values. From negative 12 to 2 is an increase of 10. From negative 2 to 4 is an increase of 6. From 4 to 6 is 2. From 6 to 4 is a decrease of 2. And then from 4 to negative 2 is a decrease of 6. Well, none of those are the same. So I don't have a constant rate of change, which means I don't have a linear function. But what I'm going to do is check my differences a second time because quadratics are x squared. So I'm going to check it a second time and see what happens. Well, my difference here is negative 4 because I'm decreasing by 4. This is also a decrease of 4. And a decrease of 4, and a decrease of 4. And so you see that my second difference is the second time I looked at the rate of change. Now they are all the same. Because I had to do it on the second time, that tells me x squared, which means this is quadratic. Now the last one down here, I'm just giving a list of values. I got another option, I got two options here. I can make a table like I just did and check my differences, or I can look at it on my calculator and see what it looks like. That's what we're going to do because I want you to see that you can also use your calculator to do this. So we're going to put these values into our calculator. We're going to do x values in list 1 and we're going to do y values in list 2, which we have done before. So we're going to take our calculator, we're going to go to Stat and Edit, and in list 1 we're going to put all our x values. So I'm going to do negative 3, negative 1, 2, 3, 5. So I have negative 3, negative 1, then 2, 3, and 5. 2, 3, 5. So there are my x values. Then I'm going to go over here to list 2 and I'm going to put my y values. So I'm going to go 14, 0. And then I'm going to do negative 6, negative 4, positive 6. I have negative 6. Whoops. Apparently I had a problem. Let's try that again. Negative 6. Oh, there we go. Then I'm going to do negative 4 and positive 6. So I have negative 4 and 6. So there are my values. Instead of going and doing anything else, I'm just going to look at what this looks like. I want to see these points. So I'm going to go to second y equals, and I'm going to turn on this first plot. So I'm going to hit enter here, and I'm going to hit enter to turn it on. So the word on is highlighted. I want that first plot that's a dot plot. All the rest of my settings are good. The only thing that I have that you don't is that I can choose a color. You cannot. It's not a big deal. I'm also going to go over here to my window because I know from looking over here that my biggest Y value was a 14. Excuse me. So I want to go down here to Y max. And I want to change my maximum Y to 16 so that I can see it. Don't worry about any of that other stuff. Just change your Y max to 16 and then press graph. You should be able to now see all of your dots. There is also a graph on top of mine because, and it might be on yours too, because we have something in Y equals. We plugged something in. You can ignore that. What I want you looking at is the little squares, the dots. Okay? If I were to take my pen and trace over those dots, it makes a shape similar to a parabola. It's not a perfect parabola. It doesn't make a perfect little parabola, but it's close enough that I'm going to call this quadratic. And I could tell just by looking at the shape of the graph. And so that's, you can use a table or you can just look at the points, however you choose to do that. So let's finish up this foldable. So go to the next page. We're now on the back pink page. So we're page 6 here. We have a graph that shows the relationship between the height in yards and the horizontal distance in yards of a soccer ball after it gets kicked. And so somebody kicked a soccer ball. I made that small. Somebody kicked up a soccer ball into the air, and so this is the path it traveled. Okay, this is how high it went, and this represents how far it went. And so we're going to answer some questions. The first question says, find f of 7.5. Well, remember, from way back when, f of x is the same thing as y. And so when they tell you f of 7.5, they're saying x is 7.5. So let me change my screen again here. So we're going to go look at our graph, and I want to know where x is 7.5. And if you look at the picture here, it looks to me like every single line is worth 2.5. So this would be 2.5, this is 5, which would make this 7.5. And so they're asking me, what does y equal right there? Well, if I go over here to the side, I see that it's about 3.5. It's not exact, but it's going to be close enough that we're going to call that 3.5. Then they ask for f of 22.5. Well, f of 22.5, here's 20, so 22.5 is right there in the middle. Just scoot up a little more. So right here, it hits right here, which is about 8. It's a little bit more than 8, but it's close enough that I'm going to call it 8. Okay? Now the last question says, when f of x equals 2, find the value of x. So now they're telling you that y equals 2. So you're going to do the same thing, but we're going to use our graph. Up here, we're going to go y equals 2 right here. And if I go down, it means it right here. Well, remember, this was 2.5 and this is 5. So what could we call that something in the middle? I guess we could say that's about 4. Okay, or we can say that x equals 4 because it's close to 5, but not quite. We're going to call it 4. It's good enough for me. Okay? So now we're going to do something called a quadratic regression. You've done a linear regression where you took points, plugged them in, and it gave you the equation of the line. Now we're going to do a quadratic regression, and we're going to use those points that we had over here, right here, that we just plugged in, because they're already in our calculator. So we're going to use these points. We're going to write them into our table. So I have negative 3, 14. Shrink this back down so I can see. So I have negative 3, 14. And then I had negative 1, 0. And then I had 2, negative 6. And then 3, negative 4. And 5, 6. And these points are already in your calculator because we put them in just a second ago. So we've already entered these into the calculator. Now we're going to come up with the quadratic regression, which means I'm going to find the equation that best matches those points. And it's not going to be perfect, and it's okay that it's not going to be perfect because you can see that doesn't make a perfect little parabola. But it's close. So here's how a quadratic regression goes. We're at stat. We've already edited because we put the points in. So now we're going to go over to calc. Before, we only operated with number 4, lin reg here. But now I want to do quad reg because I want a quadratic regression. So you're going to choose number 5. Same as before, we're going to go down until we're at the calculate part, and then we're going to hit enter. And I'm probably going to get a lot of yucky decimals here, and that's okay. Oh, look, I didn't. That's nice. Okay, and so now I have 3 numbers instead of 2. And whenever you did this before, you had an a and a b but no c. But you see, this looks like standard form of a quadratic equation. Ax squared plus bx plus c. You're just going to plug your numbers in. So it looks like I have 1x squared minus 3x minus 4. So my equation for those points that we just did is going to be y equals 1x squared minus 3x minus 4. This is the quadratic equation that matches those points. And from there, I could now figure out what my vertex is, where my line of symmetry is, all of that. But now you do have the equation. That's how you do a quadratic regression. It's just like a linear regression. You just choose a different option. So let's do the back page. Let's evaluate a little bit. So we're going to evaluate function, which means I'm just going to label, and then I'm going to plug in the values. So number 1, given the quadratic function f of x equals 3x squared plus 2x minus 5, I want to find the dependent variables when the independent variables are those 4 numbers. We're going to do this twice, and then you will see that it's just you do the same thing for the rest of the numbers. Dependent variables are y, independent variables are x. So they're telling you, find y when x is these numbers. Well, that just means take these numbers and plug them in for x. So I'm going to take the first number, negative 3, and I'm going to plug it in everywhere I see an x. So I'm going to have 3 times negative 3 squared plus 2, that's plus, times negative 3 minus 5. And the nifty thing about my calculator is I can type that in and it'll do it for me. So I'm going to do 3 times, and I'm just going to do parentheses just like I did, negative 3, close my parentheses, squared, plus 2 times negative 3 minus 5. So then I have plus 2 times negative 3 minus 5. Check to make sure I typed that right. Looks good to me. Hit enter. Bam, it equals 16. So I come over here. When x equals 3, I'm just going to negative 3, I'm going to put in a table. Then y equals 16. So my answer for that one is 16. And so I would do it again. If I want to do it for 0, I'm going to do the same thing, but I'm going to plug in a 0. So I'm going to do 3 times 0 squared plus 2 times 0 minus 5. And I'm going to pull out my calculator. I'm going to do the same thing. I'm going to do 3 times 0 squared plus 2 times 0 minus 5. I'm going to hit enter. Look, the answer is negative 5. So this one is 0, negative 5. And if you want the other 2 values, you lather, rinse, repeat. Do this again. Plug in the 1, plug in the 5, get your answer back out. Now look at question number 2. Question number 2 says, given the function negative 5x squared plus 2x plus 6, find the dependent variables when the independent variables are. It's the same problem. Okay, it's the exact same problem. They're telling you find y when x is these numbers. So I'm going to plug these numbers into here and find out what they equal. So let's do the 5. This one right here. So I would do negative 5 times 5 squared plus 2 times 5 plus 6. And you'll have to do this for all 4 numbers. I'm just choosing one of them so you can see the process is the same. So I'm going to go negative 5 times 5 squared plus 2 times 5 plus 6, whoops, plus 2 times 5 plus 6. And the answer is negative 109. And so now my answer is negative 109. That's what y equals, or f of x equals, however you want to put that. You should not, at this point in the unit, be asked the question in the opposite way. It should not say, find the independent variables when the dependent variables are. You don't yet know how to solve a quadratic equation going backwards. You will, but you don't yet. So if it says that, there's been a mistake. They should all be pretty straightforward. Plug in the number and do it. So the last one, given the quadratic equation f of x equals 2x squared minus 3x plus 1, find. And then it gives you 4 things you have to find. It's the same problem. It's just worded a different way. If I'm going to find f of negative 32, that means wherever I see an x, I'm going to plug in a negative 32. So I'm going to do 2 times negative 32 squared minus 3 times negative 32 plus 1. And I'm going to do the same thing I've been doing all along. I'm going to grab my calculator. 2 times negative 32 squared minus 3 times negative 32 plus 1. And I'm going to hit enter, and it equals 2,145. That's what that comes out to, and so f of negative 32 is 2,145. If you want to know what f of 1 is, you do the same thing, plug in a 1. If you want to know f of 3, plug in a 3. It's just evaluating. It's very straightforward. Take the number they give you, plug it in for x, find out what it equals. That's all you know how to do at this point. There will be no tricky ones that go backwards. So we will practice this all tomorrow. I will see you then. Have a good rest of your day.